We all want greener air travel, right? The idea of flying without that massive carbon footprint is something pretty much everyone can get behind. But, the industry's ambitious plan for a sustainable future, well, it's hitting some serious and pretty unexpected turbulence. So let's break down what's really going on.
Okay, let's just state the obvious right up front. Flying has a pretty significant climate problem. Global aviation, as a whole, is responsible for about 2 to 3% of all greenhouse gas emissions. And here's the kicker. With air travel only expected to grow, that number is going to keep climbing unless we do something drastic. So, what's the industry's big solution? Well, it's a thing called sustainable aviation fuel, or SAF for short. You can think of it as this big umbrella term for green jet fuels. They can be made from all sorts of things, from used cooking oil to agricultural waste. And the really key part is that it's a drop-in fuel. That means it works with the planes and airport infrastructure we already have. It's the absolute cornerstone of the industry's climate plan, expected to handle over 60% of the needed emissions cut.
And boy, has the ambition been huge. Over the last decade or so, governments and big energy companies have announced this massive wave of new SAF projects. I mean, you look at these charts of announced capacity, and you just see this incredibly steep climb. It paints a really optimistic picture, right? A green future for flying, coming right on schedule.
But that's the big question, isn't it? With all these flashy announcements and ambitious targets, is the industry actually delivering the goods? Is all that promised green jet fuel actually making it into the wings of planes?
Well, the answer is pretty stark. Of all the sustainable fuel capacity that was promised to be up and running by 2024, only 24% of it actually got delivered. Just think about that for a second. That means nearly 3/4 of the green fuel we were told we'd have, it never happened. And what's so powerful about this slide is how clearly it shows this realization gap. So those top lines, that's all the capacity that was announced year after year. The solid black line way down at the bottom, that's what was actually built. And you can see the gap between the promise and the reality, it's not closing. In fact, it's getting wider every single year.
So what is going on here? Why is there this huge chasm between the plans on paper and the actual fuel in the tank? Let's dig into the real reasons so many of these projects are hitting a wall.
Turns out, you can't just point to one single problem. Each type of SAF technology has its own set of hurdles. For HEFA, which is the most common type using oils and fats, the biggest headaches are just getting enough raw material and competing with fossil fuel on price. For another type, Fischer-Tropsch, the projects keep hitting technical roadblocks. And then you have power to liquid, this super futuristic idea of making fuel from air and renewable power, where the tech is just way too new and expensive to scale up right now. But if you zoom out, you do see these common themes popping up again and again. Projects are getting delayed or canceled because, frankly, they just can't compete with the cost of regular jet fuel. Regulations aren't stable enough for investors to feel secure, and some of the key ingredients for the more advanced fuels, like green hydrogen, are really hard to come by. It's basically a perfect storm of economic, regulatory, and technical barriers. This chart really shows you exactly where all those promises went. See that tiny green slice at the bottom for 2024? That's the 24% that actually became operational. And the rest? A huge 45% got delayed, and another 31% just went inactive or failed completely. It's a massive detour from the goal we were supposed to be hitting. Okay, so given this reality gap, what does the future actually hold? Well, to try and figure that out, researchers built a couple of data-driven models, and they based them on how similar energy technologies have scaled up in the past. And this gives us two pretty different potential futures. On the left, you have the slow path, which imagines SAF growing at the same kind of steady but not amazing rate of early biofuels. But on the right, you have the rapid path. This is the best case scenario, where SAF just takes off with the same explosive, game-changing speed that we saw with solar and wind power. And this is really the bottom line. The slow path misses the 2030 global target by over 15 million tons. But here's the stunner. Even the best case scenario, the one that grows as fast as solar and wind, still falls short by almost 10 million tons. So no matter which way you slice it, we are not on track.
Let's just put a single number on that best case scenario. Even if SAF scales up as miraculously and as quickly as solar and wind did, we are still projected to miss the 2030 global target by 42%. That is not just a small gap, that is a massive chasm. And listen, this isn't just a short-term problem we can fix later. If you look all the way out to 2050, even decades of that super fast solar-like growth still isn't enough. The industry is aiming for net zero, but this projection shows we'd still be missing the mark by a long shot. The path we're on right now simply doesn't get us to the finish line.
Okay, so the current plan clearly isn't working. The gap between what we want and what we're getting is huge. The obvious question then becomes, what on earth can we do to actually close this production gap and get SAF on the right track?
The first and maybe most critical lesson here is for policymakers. You have to stop counting promises as if they're reality. Company announcements, as we've seen, are often just that, announcements. They can be great for PR, but they don't always translate into actual fuel production. We need to look at what's actually being built.
So, what's the playbook from here? Well, it seems to be a three-step process. First, we have to learn from what worked for solar and wind, things like stable, long-term government support that gives companies certainty. Second, we need to get specific with policies that attack the exact cost and tech problems holding SAF back. And third, we have to stimulate supply right now to give investors the confidence they need to actually build these expensive factories today, not 10 years from now.
And just to really wrap your head around the scale of this challenge, think about this. To meet that 2050 net zero target, SAF capacity has to grow by 23% every single year for the next 25 years. That is a growth rate that's on par with the global expansion of nuclear power during its absolute peak in the 20th century. This is a monumental industrial undertaking. There's no other way to put it.
And all of this leaves us with one final and pretty critical question. The ambition for green flying is there, for sure, but the reality of production is falling dangerously short. The road ahead requires unprecedented growth, unwavering policy support, and frankly, a bit of a reality check. The challenge is immense, and it really makes you wonder, can we actually close this gap and make sustainable flying a reality before our climate goals fly completely out of reach?